Okay, so today we're going to be talking about how it's kind of like what we did at the end of yesterday's class. Speaking of yesterday's class, you had a homework question, and I may put the answer up, but I don't know if I'll have time to do that part today, but we will go over it tomorrow. So don't forget to do that word problem question, which was number 13. Number 13 on page 370, or 371. Okay, so don't forget to do that one. But today we're going to take a look at how you can solve quadratic equations by graphing, finding the roots. Okay, so we're going to look at finding the roots of the quadratic equation. So before we were talking, when we label it y equals, and then like y equals x squared plus 5x plus 6, if we looked at the first example, if we said y equals that instead of x squared plus 5x plus 6 equals 0, when we say this, y equals x squared plus 5x plus 6, then we would refer to that as a relation. It's an equation that relates the x and the y values. If we look at this one, the difference is that the y value is 0. So this we call the quadratic equation. Again, it has degree 2, and the standard equation would be ax squared plus bx plus c, the same as what we've seen before. Okay, so when they refer to a root or a 0, and they're referring to the quadratic equations, it's basically a value of the variable, so the x variable, that makes the function or the equation equal to 0. In other words, it's the values of x that make the y value be 0. So if you look at this particular graph, these are the two zeros, the two roots. Okay, so if we look, the value of x, this one is x equals -3. This one is x equals 2. So when we plug in -3 for x into that equation, then it should give you a 0. When we solve both sides, we see that it is one of the x values that would give 0 for the y value. Okay. Roots are values of the variable that make the equation equal to 0. So again, zeros are the same as roots. And what we've talked about to date, we've described them as the x-intercepts, because the x-intercepts are where the graph crosses the x-axis. Okay? So when we talk about the different kinds of parabolas you can have, depending on its location in the coordinate plane, it may have two roots, meaning it has two zeros or two x-intercepts, where the x values would give a y value of 0. Okay, so the y coordinates there are 0 because they're along the x-axis. There could be one where there's just one root, so that would be at the vertex. Or it could be that there's no roots, because if you look at this one, it never touches the x-axis. Okay, so y can never be 0. It's either above or below the x-axis. Okay, so when we're talking about the roots or the zeros and they're asking you to find that, they're asking you to find the x values, the x coordinates, where the y would be 0. So you'd either have the possibility of having two of them, one of them, or none, depending on where that graph falls. So if we took this example, you can still use your graphing calculator. So instead of putting 2x squared plus x minus 4 equals 0 into a calculator, you have to do y equals, right? So you'd put y equals, and then in the box you'd put 2x squared plus x minus 4. Okay, so if we wanted to find the roots, this is what we did yesterday. You might not remember because it was at the end of class. Basically, we want to find where the parabola intersects with the x-axis. So while that's opening, I'm just going to try and remember it's 2x squared plus x minus 4. Okay, 2x squared plus x minus 4. 2x squared plus x minus 4. So we click on graphing calculator, and we put 2x squared plus x, oh, and I delete, oops, plus x minus 4. Okay, so then I would click in the second one, and I want to see where it intersects with the y-axis, or sorry, the x-axis. So for us to describe the line that is the x-axis, we call it y equals 0. So basically we're finding out what are the points on that first graph that have a y value that'll be 0. So we'll graph, okay? So the blue line, which is the x-axis, is actually that line y equals 0. And we're going to get it to tell us what these two values are. Okay, what are those two x values? To tell us the roots. So to do that, you click on the intersection tab, and this is what will come up. So as long as your two equations are selected, so you have the circles in them, the dots in them, then you click on plot the points of intersection, and it shows you. Okay, you probably have to do this on your own to be able to see them big enough. Okay, but the x-coordinate right here is negative 1.69. So one of the roots is x equals negative 1.69, and the other one is x equals 1.19. Okay, so those are the two values of x that would give a y value of 0. They're also known as the x-intercepts. Okay, so that is how you would do it on the graphing calculator. If you were to do it by hand, it's a matter of doing your table of values, graphing the parabola like normal, and then finding the x values where they cross the x-axis. All right. So I'm going to get you to pause the video for a second, and I want you to try and find the roots or zeros of the two examples that are given. Okay, so press pause and try them, and then go back and play, and we'll go over the answers. Okay, so I'm assuming that you paused it, you tried to do it on your own, and now we're going to quickly go through the answers. So 2x squared plus 5x plus 3. So you would have gone to the equation part, and you'd have 2x squared plus 5x, I think it was plus 3. 2x squared plus 5x plus 3. Plus 3. Okay, and we still have y equals 0. So we'll graph. Okay, and now we're going to do intersection. And we click plot the points of intersection. Alright, so can't see them very well. If I want to, I could zoom in, and zoom in again, and zoom in again. Oh, that's too far. Okay, so you can also change your scales if you want, but this one says an x value of negative 1.5, and this one has an x value of negative 1. Okay, so those are the two roots, the two zeros. If it said how many roots are there, then you'd say there's 2, because it crosses the x-axis in 2 places. So it would give 2 possible chances of having a y value of 0. Alright, now we're going to try it for 2x squared plus x plus 2. 2x squared plus x plus 2. So 2x squared plus x plus 2. Alright, let's graph again. Oh, don't even see anything on there except for the x-axis. So let's see what happens if we zoom out. So are there any roots? Does it cross the x-axis? No. So you would say no roots or no solutions. No solution. If we were to try and do the intersection, okay, intersection, and then plot points of intersection, oh, it comes up with an error because they do not intersect. Okay, so there's no solution or no roots for that one. Okay, it just means it does not cross the x-axis, so there's no x values that could give a y value of 0. All right. Now, the next part, we're going to kind of skip over this part. Your homework tonight is, and for the rest of class, after we finish covering things, is going to be number 1 to 4, page 379. But I wanted to show you another way of figuring it out. Okay, so in each of the previous examples, let's see, I'll make this a little bigger. In each of the previous examples, they were already solved to be in standard form. So this is another option that you can have if they're not solved to be in standard form. Okay, so method 1 is just like what we had done before. Okay, this one says x squared minus 6x equals negative 9. I'm looking at the example we're supposed to do. So in method 1, we would simply rearrange it so that we set it up so it's equal to 0. And then we can graph it like we had done before. So in order to make it 0 on the right-hand side, I would have to add a 9 to both sides. Okay? So that means you'd have plus 9 equals 0. I would graph that and graph y equals 0 and find the points of intersection, just like what we had done. The other way you could do it is to graph each half. So you're going to make a graph for y equals x squared minus 6x, and instead of the second graph being y equals 0, you're going to graph the other side of the equation, y equals negative 9. Now the first one is going to give you a parabola, okay? The second one is going to give you a line. The answers are the x values of where those two graphs intersect. So they're not going to be necessarily on the x-axis, they're just going to be where those two intersect. So that's another way of doing it. It might confuse some people a little bit, so just be careful how you do that. But let's see. X squared minus 6x and x equals negative 9. So we're going to, oh, I don't know why I did that. Anyway, so we have x squared minus 6x, and this one is x squared equals negative 9. Okay, so we're going to graph the two. Oh, we might need to zoom out. Okay, so how many solutions are there? There's only one solution. Should only be one solution. Okay, and that would be at the vertex where they're going to cross. Okay, so we're going to find where they intersect. Oops. Oh, I have to get rid of the drawing I did. Okay, click on intersection, make sure the two equations are picked, and find where they intersect. There should be one point of intersection. Great. Okay, go back and make sure I did it right. Graph. Okay, so if I hover with the mouse, it should be right about where it's at, but I will double check that one. Let's go back and try it the other way. Okay, so it should be, did I pick the right? Yeah. Now where did it go? Sorry. Okay, so x squared minus 6x, if we just did the one and did it the old way, so you have plus 9, and I make it, see where it intersects with y equals 0. Okay, so it should have one point of intersection. So if I click on intersect, why is it saying that? Maybe they don't quite meet. I'm really, really sorry. That is what you do. Okay, obviously it wasn't a good equation to choose. Because it's not working out that way. Anyhow, we're going to do, oh sorry, I'll leave that. We're going to do the same sort of thing for this equation, and hopefully this will work a little bit clearer. So if we, for method 1, we're going to rearrange it. So we'd have x squared plus 2x, move the 8, so we have to subtract 8 from both sides, minus 8 equals 0. Okay, this one, we're going to be graphing two things. So we have x squared plus 2x, and then we have x equals 8. Oh, sorry, y equals 8. Y equals x squared plus 2x, and y equals 8. You don't really need a table of values for this one, but you do for the first one. So if we put in a 0, then you'd have 0 squared plus 2 times 0 is 0. If we put in a 1, 1 squared plus 2 times 1, so you'd have 1 plus 2 is 3. If we put in a 2, you have 2 squared, which is 4, plus 2 times 2, which is 4, so we get 8. If we put in a negative 1 squared is 1, plus 2 times negative 1 is negative 2. So 1 and negative 2 makes negative 1. If we put in a negative 2, negative 2 squared is 4, plus 2 times a negative 2 is negative 4. So that would be 0. So I think we found the vertex. Okay, so we plot negative 2 and 0, negative 1 and negative 1, 0, negative 1 and negative 1, 0 and 0, 1 and 3, 2 and 8. Okay, that's a little bit off. There. Okay, so we would expect, if we follow the right pattern, that for negative 3, it would be 3. And for negative 4, it would be 8. Okay, so there is the parabola. And y equals 8. Oops, that didn't go down far enough. Y equals 8. Y equals 8. So for every value of y, every coordinate, the y has to be 8. So this would be y equals 8. Okay, so the answers are the x-coordinates for the points where those two graphs intersect. So we'd have negative 4, and we'd have a positive 2. X equals negative 4, and x equals 2. Okay, if we did it by rearranging, then you'd have put in a 0, 0 squared plus 2 times 0 minus 8 would be minus 8. Put in a 1. 1 squared is 1, plus 2 times 1 is 2, so that's 3, minus 8 is minus 5. Put in a 2, 4, or 2 squared is 4, plus 2 times 2 is 4, so 8 minus 8 is 0. Put in a negative 1, negative 1 squared is 1, plus 2 times negative 1 is negative 1, minus 8 is minus 9. Put in a negative 2, negative 2 squared is 4, plus 2 times negative 2 is negative 4, so that's 0, minus 8 is minus 8. So we have negative 2 and negative 8, negative 1 and negative 9, oops, 0 and negative 8, my board's not quite right, 1 and negative 5, that's supposed to be down a little bit, and 2 and 0. Okay, on the other side we expect it to go the same thing, so negative 3 would be a negative 5. So negative 3 and negative 5. Oops, sorry. Sorry, that's way too high. Silly. Negative 5, negative 3, and negative 5. And then negative 4 should be at 0. Okay, so here's the parabola. And if you did it using method 1, it's the x-intercepts. Okay, the x-coordinate of the x-intercept. So x equals -1 and x equals 2. Are they the same? Yes, but it's two different ways of doing it. Just depends if you would rather rearrange the equation first or do each side separately and see where they intersect. Okay, so some of the questions in 1 to 4 ask you to do it one way and some ask you to do it the other way. You can have a choice, but you should kind of be familiar with both. You can use the graphing calculator to double check. You know how to graph the things, okay? But most of the time you will be able to do this using the graphing calculator. So if we did it using the graphing calculator, and you don't have to watch this if you're okay. That's the last of what I was going to show you. So it's numbers 1 to 4 in your book. And that is page 379, 380. Okay, if you want to watch this, then you can. So we have, if it's solved, if you're doing both sides, so you have y equals x squared plus 2x on the one side, y equals x squared plus 2x, and then the other one was y equals 8. Okay, that's the right hand side. Y equals 8. And if we graph them, we might have to zoom out, and you can see where they cross. So the answers are the x-coordinates where the two things intersect. Okay, so it should be -4 and 2. Now we're going to try the intersection and see if it works this time. Okay, click on intersection, plot points of intersection, and there you go, -4 and 2. So you have x equals -4 and x equals 2. Okay, so please try numbers 1 to 4. I don't know why the other one didn't work, and I apologize for the confusion. I should have tried it before doing the video. But anyhow, it was probably a little error that I made, and I apologize. I'll make it up to you tomorrow. Work hard, work well, because I really want to have a good report back. Thanks. See you tomorrow. Bye.